Okay, just to check, can you guys see my camera? Is it clear? My video. Can Okay, good. All right, let's start. By the way, both of you guys study in English, right? Just want to check that first for maths. Both English, right? Okay, so I can use English fully today. Okay, this one, full screen. Okay, can you guys see the screen? Just want to check. Is it clear for all of you? Clear? Okay, good. All right, so let's start, guys. Wait, let me zoom in. View 200. Okay, so guys, basically today we are going to learn on this chapter, which is probability of combined events. Okay, so guys, do you all know you also studied this chapter, right? Before this probability. Do you know when you studied this chapter? Before Form 4? If anyone remembers, before your Form 4 probability, when do you study this? Any idea? Form 1, Form 3, yes. Yeah, basically lower form lah. Okay. Yeah, it's okay. Don't care what form. But lower form, you guys got study, right? Okay, that is the simple probability. Okay, if you guys remember, that is the simple probability that you all study. Now, in Form 4, they make it slightly more advanced for you guys. Okay, they add combined events. When you guys learn in lower form, we were talking about probability of a single event. Do you all still recall? Like they say that you got 5 balls and then 3 are red balls, and then they ask you what is the probability of getting red ball. What is the answer, guys? Can you tell me? That is simple probability. Simple question. Total 5 balls, 3 red balls. What is the probability you get a red ball? Anyone? Can you comment the answer? Simple one, yeah. Okay, the answer is 3 over 5. Yeah, simple as that, right? That's why we call it simple probability. And that is one event, correct? But now we are going to look at combined events. Combined events means 2 or more. Okay, they won't just ask you on one event because that is very simple. You guys already studied before. So Form 4 is level up. We talk about combined events, means 2 or more events. Okay, so yeah, basically this is what the chapter is going to teach you. So this chapter actually got total 3 subtopics that you guys must know. First part is on combined events, as you guys can see the name here. And then second part is on the dependent and independent events. And third part is mutually exclusive and non-mutually exclusive. Okay, so for today, since it's 1.5 hours, I feel that we can cover 9.1 and 9.2, which is the combined event and also the dependent and independent event. Okay, so that is not so rush for you guys. Okay, we can slowly do the question and also learn the concept. Okay, guys, are you clear with our target today? Both of you? So this is what we're going to focus today. 9.1 and also 9.2. Okay? Can Okay, clear. Okay, continue. Okay, so yeah, these are the subtopics you guys can see. Combined events, dependent events, independent events. And then, wait, let me get the pen. And red color. Okay, so yeah, dependent events, independent events. These two we will see the next class. Okay, mutually exclusive, non-mutually exclusive, and also the application. Okay, this one we'll leave it for next time because it might be too heavy for you guys. Okay, all right. So guys, probability in daily life. I think you guys know, right? What is the application of probability in daily life? There are a lot of applications that you guys can see in daily life for probability. Okay, so one example here they actually put in your textbook is, okay, how does the coach select the players to be defenders, midfielder, and striker? Okay, do both of you play football here or not? Alex and who? Shane. Do you all play? Play, right? In PFS. Okay, so if you guys got play football before, you guys will form a team first, right? Before you start the match, correct? How many people you guys usually have in one team? Let's say you guys play for fun. How many people in one team? May I know? Total. Okay, 8 to 11. Okay, let's say we take 8 people. Okay, let's say we assume 8 people. So guys, from these 8 people, right, they need to be divided into defender, midfielder, and striker. Am I right? I think you guys also play like that, right? You said like, okay, these 3 people may be defender, these 2 people may be midfielder, these 3 people may be striker. Correct? if 8 people. But the standard is 11 people, of course. But let's say you got 8, this is how you put the formation, correct? Okay, so how to know, guys? How do you guys decide among yourself which should be defender, striker, and midfielder? May I know? Nothing to do with maths, guys. Logic, common sense. How you guys decide? Based on what, actually? Who gets the defender, midfielder, and striker role? How to decide? Based on what? Yes, case skill and capability. Okay, for example, striker. Striker, what is the skill he must have? Must be fast, must be accurate in shooting. These are two of the skill. Must be good maybe in how to say, counter the opposition defense, correct? Then midfielder, what skill must he have? You guys also know, right? Midfielder, you need to start the attack and also defend, protect your defense. So midfielder, that's the capability. Defense, what is it? He must be strong, okay? Must be able to fend off the attackers, correct? So all of this is based on the probability of how good their skills are. So if let's say the probability of a person is 1 in attacking, so where do you put the person, guys? Common sense. Let's say a probability of a person to attack is 1. So you put him in defender, midfielder, or striker? May I know? Simple question. So where you put him? Yeah, of course, striker lah. Am I right? Because he has a high chance to score goal. Okay, it's based on the probability of scoring the goal. Okay, and yeah, basically this is how they select lah. Okay, this is one of the example only. Any other example that you guys know that you can see probability being used in daily life other than this one here about football? Anything else? It can be outside of sports also. Try to think and see, both of you. Any example involving probability that you might have seen? Selecting prefects based on their value. Oh, something very closely related to you. Okay. Yeah, Ken, no problem. That is also probability, correct? Anything else? Another one? Another example that is maybe not so closely related to you? A random example? Now we just brainstorm first, guys, before we really enter the topic. Let you guys think of ideas first. Shane, also you can try. What example of probability you have seen in daily life? The very simple one. No need to go for bombastic ideas. Duration of time. Spinning. Yes, very good. Spinning head or tails of a coin. Correct. And then Alex, duration of time. Duration of time. What do you mean? Time for what? Can you be more specific? Yeah, the most practical example basically is the coin. Whenever we talk about probability, that is the main example we use. So guys, what is the probability of getting a head? Can you tell me when you flip a coin? Yes, okay. Alex, is actually slash, divide. Okay, if you write like this, it means ratio. Okay, 1:2. This is not probability. Okay, probability, you must always write in fraction. So it's 1/2. Okay, 1/2. Or you can say 0.5 also can. Okay, are you clear with that? Don't write in ratio, guys, both of you. Remember, probability cannot be in ratio. Okay, must be in fraction or decimal. All right? Okay, next one. Okay, so why you study this chapter? Basically, they show you the example here lah. It's like to determine the amount of insurance premium, and then you also use especially in risk management. Okay, another example is probability is let me think. Let me try to give an example. Okay, do you guys play the card games or not? Both of you. You know the card games where they have like the king, queen, spade, all that. Yeah. Okay, when you guys play that kind of games, right? Okay, not talking about gambling. I mean, normally when we play, it's based on probability, right? Whether you get the card that can help you win is totally based on probability. Okay, it's based on luck, correct? Not much skill involved. So probability is basically talking about luck, the chance. Okay, so yeah, that is another example that you can see also. Okay, and then yeah, this one no need. Okay, another thing you can see probability is this one, guys. Do you all play this game, rock, paper, scissors? I think until now still have, right? If not mistaken. Wait. Yeah. I think you guys got play, right? Okay, yeah. Okay, rock, paper, scissors. Okay, this one is basically to determine the order between people. Who goes first, who goes next, correct? So you can see among these three, right, there are many possibilities for two people to get. You can see here 1, 2, 3, 4, 5, 6, 7, 8, 9. There are total 9 possibilities between rock, paper, and scissors to choose two people, the possible outcomes for two people. So guys, these 9, right, in probability, we actually have a name. Do you all know what is the name we call for these 9 outcomes? There is a specific name we call all of this. Do you all know? Yes, very good. Okay, the answer is sample space. Okay, we call this as sample space. Okay, whenever we're talking about a total, we always use the word sample space. Okay, more professional lah, guys. Between saying total and sample space, which one looks more professional? Of course, sample space, right? So in probability, we always use the word sample space to represent total. Okay, so you can actually represent the outcomes of any event by using ordered pairs. Okay, this is what we call as ordered pairs. Okay, ordered pairs is like coordinate, guys. Can you see? This is in the format of coordinate, like x coordinate and y coordinate, something like that. This is what you call as ordered pair. And the order is important, guys. You can see here, scissors, paper, and paper, scissors. Can you see? They separate it into two. We cannot consider it as one. Why? You all know why we need to separate? Cannot just choose one and write. What do you think is the reason we need to separate it? This one is something you guys can think about. You see here, okay, scissors, paper, and also paper, scissors. Why we need to separate it into two separate ordered pairs? Why we cannot just leave it as one? Yes, very good. Okay, because the outcomes actually, when the order is switched, is actually significant. Okay, there is a different outcome. It's not the same thing. That's why we need to write two separately, because the order is important. Okay, later when you guys go to Form 5, and maths, both of you take ad maths, right? If not mistaken. Shane and Alex. For Alex, don't take ad maths, but Shane take. Okay, for Shane, if you go to Form 5, and now you're Form 5, right? Sorry. Have you studied permutation and combination? Maybe I can explain this better for you from that concept. Have you studied Form 5 Chapter 4? Or okay, not yet. Then it's okay. Don't need to explain yet. Later you get more confused. Just understand it from the point of view of maths first. Later, maths will explain it more detail to you. Okay? Since this is maths, we just focus on maths. Alright? Okay, so now guys, how to know the number of possible outcomes for an event? Okay, basically we are using this rule. Okay, NS is equal to NA times NB. Okay, this is called as the multiplication rule. You can call it multiplication rule. Yeah. Okay, so basically is you times the number of outcomes of both events separately. That is how you get the total number of outcome. Okay, you can see NA times NB. Okay, NA is the number of outcomes for event A, and NB is the number of outcome for event B. So very simple formula, right, guys? Do you see? I think it's quite easy to understand. So you just need to identify the number of outcomes for both of the events separately. Then just times them. You get the sample space. S is sample space, guys. Take note. Okay, the S, whenever we use the symbol S, is to represent sample space. Okay, S, capital S. Alright? So far clear, guys? Until now? Any question so far? Before we go to example? Clear? Okay, so now guys, you need to know how to write sample space. In Form 4 Chapter 9 probability, this is very important. Okay, you must know how to write the sample space. Okay, so this situation, you have 5 cards. Usually just assume for each question in this topic is multiplication. Okay, I explained to you. Okay guys, both of you. Why we use multiply is because it is happening at the same time. These two events, they happen at the same time. When two events happen at the same time, then only you can use multiply symbol. Do you get me? If it happens at different times, you use plus symbol. That's the difference. Same time, multiply, different time, plus. Simple as that. Okay, so you just need to identify, do they occur at same time or not? How to know? Based on logic lah, guys. Okay, it's based on the logic, whether it occurs at same time or different time. Okay, so yeah, you can see here, there are 5 cards labeled TEKUN, they put into a box, and then they say 2 cards are taken out at random. Okay, why must be random, guys? Do you all know the reason? Why is it important to be random? This is another, can say, hot question for you guys to think. Why is the word random so important over there? Any idea? Shane and Alex? Okay, Alex, any idea? Okay, so basically, random, why must it be random? Is so that we ensure it is fair. Okay, there is no bias. Okay, if it's not random, means I can say, okay, let's say I like the letter U. I search all the card and then I take out the letter U. Can you see? Will it affect the probability finally? Yes, it will affect because you are biased. You are choosing. Okay, let's say I like letter K, so I will search for the letter K card and take it out. Can you see, guys, the difference between randomly picking and searching for the card and taking it out? So that's why the random is very important, so that the probability you get is fair. It's a fair investigation or fair event that is happening. Okay, so random is very important. And then one by one, okay, they take it out one by one. Means you don't take 2 cards at the same time. You take first card, then you take second card. You can see it's very specific. Okay, and then somehow they say without replacement. Okay, means when you take the first card, you cannot put it back inside. You take the first card, it's already out. Then you take the second card. So guys, if you keep taking out cards, what happens? What happens to the total number of cards in the box? You take 1 card out and then you take the second card out. So total, what happens? Yeah, total keep on decreasing. Decrease by how much, guys? May I know? For each card, how much the total decrease? Yeah. Okay, after you take out 1 card, total decrease by 1. Take out another card, total keep on decrease by 1. So from 5 become 4. 4 become 3. 2 cards taken out already. Okay, so yeah, very detailed kind of situation. So they ask you to write the sample space. So basically, you must list down all the possibility, guys. Okay, there is a lot here, but go step by step. Basically, you just pair the letters together. TE, TK, TU, TN, and then you go to E. ET, guys, you need to list down both, okay? There is a difference. TE and ET is different. Don't just write down either one. You must list down both, okay? Because the order is important over here. Because they are taking out one by one, not both at the same time. Okay, if they take out both at the same time, then TE and ET, does it make difference, guys? May I know? If you take out 2 cards at the same time, do I need to write out separately TE and ET? Or just write 1 is enough? If I take out at the same time, 2 cards. Any idea? Do I need to write both of the sample space or just choose 1 and write? Why both, guys? Guys, 2 cards take out at the same time. So is the order important or not? May I know? Different from the question, guys. Question A, they say 1 by 1. But now my own question is, I take out 2 cards both at the same time. So do I need to write out both or not? TE and ET. No need, right? Okay, because the order doesn't matter already because you're taking out both at the same time. So you just choose 1 and write. Depend on your preference. You either choose to write ET or you choose to write TE. No problem. Anyone. Okay? So yeah, this is the answer for part A. And take note, guys, your bracket must be curly. Okay, can you guys see here? If you guys use this bracket and write down your probability, your sample space is wrong. Can you see, guys, the difference? This is what we call as square bracket. This is what we call as curly bracket. Square bracket not accepted in SPM. Cannot. Okay, curly bracket only can for your probability sample space. Okay, take note on this. Always use curly bracket, not square bracket. Okay, and every time you write a new ordered pair, you must have a comma. Can you see, guys? After every new ordered pair, there is a comma. Comma, 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 all the way. Cannot leave out 1 comma also, okay? Every single thing must have comma. And then, inside, over here, also must have comma. Within the ordered pair, each ordered pair, must also have comma between everything. So take note, guys, when there is a lot like this, you miss out one comma, totally wrong. Although your letter all correct, you can still lose mark. Okay, so be careful with this, especially when you list down many sample space like this. All right. Okay, clear? Part A, no problem. Okay, so now part B, yeah? Okay, so now they say two coins are tossed. Okay, you got 2 coins now, guys. And they say T and H is tail and head. So what is the possible sample space? Can you guys give it a try? Or you just tell me the number. No need to list down one by one. Tell me totally how many sample space you have for part B. When 2 coins are tossed, what is the possible outcome? Okay, only 2. Are you sure? Total number of outcome, guys. You need to consider everything. When you toss 2 coins, how many tail and head you can get? Yeah, okay, the correct answer should be 4. Okay, you guys can see here, you have 4. Okay, tail, 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 head, tail, and head. You guys can experiment yourself. You just need to toss 2 coins in front of you, and then you see what's the outcome. Okay, you may get both also tail, both also head, or, okay, TH and HT. Is the order important, guys? Yes or no? Of course, it's important because these 2 coins, right? Did they say the 2 coins are similar? Let's say 50 cent and 50 cent. Did they specify it must be the same type of coin or it can be any type of coin? You see the question. Okay, they say 2 coin or toss. So I can maybe take a 10-cent coin and also a 50-cent coin and toss. So their shape is totally different, right? So that's why the tail head and head tail, you must consider 2 arrangements because you can choose totally 2 different coins. Doesn't mean must be the same value of the coin. Okay, do you guys get it? Both of you for part B? Can clear. All right. Okay, so now we go to some more exercise for sample space. Basically, 9.1 is talking about sample space only. You guys must understand the concept of sample space. Okay, so now you have 2 books chosen at random. You see, guys, they always like to use this keyword, random. Okay, must be random because when you do investigation, there can always be bias. Okay, there's always a possibility of bias. So to avoid the bias, we have to make sure it is random. Okay, so that the probability is fair. Okay, so now 2 history books, geography book, and mathematics book. Okay, you can use the symbol H, G, and M, like what the question say. Okay, so how many sample space, guys? May I know? Totally. You can use the multiplication rule also here, guys. You don't need to list down one by one. If you use the multiplication rule, you can tell me how many sample space you can find from here. Any idea? Just tell me the number only. Yes, very good. Okay, because you see, yeah. Shane, be more confident with your answer. Okay, don't put question mark. Okay, be like Alex, confident, 6, and then full stop. Okay, if you put question mark, means you're not so confident about the answer. Okay, so very simple. HGM. Okay, you got 3, right? Total here is 3, and then they say got 2 books. So guys, simple. 3 times 2, how many? 6. You already get the answer. Then, of course, you list down one by one. But you can direct know the total already using the multiplication rule. Okay, you guys can see here. Okay, but, okay, over here special a bit. Okay, why special? Because there is 2 history book, guys. Okay, be careful. I also almost overlooked that one already. Okay, there is 2 history book, 1 geography book, and 1 mathematics book. So total is actually 2, 3, 4. 4. Okay, you have 4. And the total here is 7, 8, 9, 10, 12. Okay, you have total of 12. Okay, wait, where's my mouse? Yeah. Okay, total of 12. Okay, so basically these 2 history book, right, guys, you need to split it. Okay, you need to split it to H1 and H2. We give label so that it's easier. Okay, since there are 2, we write H1, H2. So you need to pair it up with everything. H1, H2, H1G, H1M, H2, H1. These 2 are also considered different, guys. Do you know the reason? Why is it different? Both are history books, but how come we separate it into 2? It's the same genre, but we put 1 and 2. Anyone know the reason why? We need to separate to H1, H2. This one is a bit of logic, guys. When you take 2 history books, are they completely the same? Yes or no? This comes to logical thinking already. Let's say you choose 2 history books randomly from the library. Are they of the same content or different? You think and see. Same or different? Alex and Shane, what do y'all think? Yeah, of course, gonna be different, guys. It's impossible you take 2 books that are 100% means the word also same content. Impossible, right? Okay, confirm there is difference. So that's why we need to split it. Okay? Yes, but the order will change because an additional book is added. Yeah, correct. Okay, 2 also. Yeah. Okay, so that is why you guys need to split it to H1 and H2. Okay, and then H2G, H2M, and then GH1. Okay, you can see you must switch the order, guys. Okay, always you need to switch the order. Okay, that's why it's basically times 2. Okay, at the end. So you have 6 on top here, and then you times 2 after you switch all the orders. Okay, do you understand, guys? Question 1. Clear? Clear? So just remember, be careful. When they say 2 history book, you need to split it to H1, H2. Okay. Children's gender for family of 2 children. Okay, guys. This question a bit controversial, but it's okay. I must ask, how many genders we have in this world? Uh, Lucky you guys still correct. Nowadays people will say more than 2, but it's okay. We assume 2. Okay, 2 genders only. M and F, male and female. Okay, so now sample space. How many total? Children's gender when you got family of 2 children. Very simple. Means when the 2 children they are born, what is the possibility you can get? Okay, yeah. Okay, male, female, or boy, girl is the same. Okay, so yeah, total is 4. Okay, boy, 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 girl, boy, and also girl, girl. Guys, why this one need to separate? Why boy, girl, and girl, boy need to separate to 2 cases? Again, comes to logical thinking. They are considered the same. What? Why we need to split it to 2 separate ordered pairs? Based on what? Why do we split it? Uh, this one a bit more towards bio already, but hopefully you guys can think of the reason if you guys take bio. I think Shane takes different order of outcome. Yes, correct. Okay, when the family gives birth to the mother gives birth to the children, the order matters, right? Maybe the boy comes first, then the girl, or the girl comes first, then the boy. Correct? That is why we split it to 2 cases. Can you see, guys? It's also based on logic. Okay, so yeah, that's why we need to put 2 cases here. All right. Okay, next one, number 3. They say a fair dice is rolled and a fair coin is tossed simultaneously. Simultaneously means what, guys? Do you all know? In maths, you guys solve simultaneous linear equation. Yeah, simultaneous means same time. Okay, happen at the same time. Okay, so yeah, fair dice and fair coin. So how many outcomes, guys? May I know? Okay, you guys must know fair dice means what? Do you all know? Total number, how many? Yeah, okay, that's the final answer, right? Okay, yeah, so basically fair dice is 6 and fair coin is 2. Okay, the number of outcomes. Okay, fair coin is head or tail, and then fair dice is 1 to 6. Okay, so 6 times 2, 12. So you can label it like this. Okay, 1T, 2T, 3T, 4T, 5T, 6T, 1H until 6H. So total 12. Okay, guys, why they say must be fair dice and fair coin? Do you all know the reason? Why not they just say a dice is rolled and a coin is tossed simultaneously? Why they emphasize on the word fair? Do you all know the reason? This one also a lot of people don't know. How about Alex? Do you know why must be fair? Fair dice and fair coin? Why not just dice and coin? Logic also. It's a logical thinking question. Yes, very good. Okay, there are dices more than 6 actually, and in that way it won't be fair. Okay, because if more than 6, you will have certain number, the probability of getting it will be higher. So that is already not fair to this question. Okay, so yeah, that's why it must be fair. And coin also. Coin, it must be fair also because there may be certain coins that are biased also. So maybe certain side will have a higher chance to get the spot where it lands. Okay, so yeah, must be fair. Then only you can carry out the investigation. Okay, next one. Question 4. Okay, Asa and Kai Meng play a maximum of 5 badminton matches. The player that wins 3 sets is the winner. Okay, so this one you guys must think also lah. If you guys play badminton, you guys know how to do the question. So how many sample space you have? 5 matches, 3 set is the winner. So any idea? You can use the symbol A and K, then you can find out the total sample space. Anyone? Final answer? How many you have sample space? Okay, let's see. Okay, so got a lot. Okay, there are a lot of outcomes, guys. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. Total is 20. Okay, too much already. You overestimate. Okay, total is 20, guys. Total 20 outcome. Okay, A is for Azhar and K is for Kaiming. Okay, so basically, you must think lah, guys. There are a lot of ways because they say 3 sets is the winner, right? You mean you win 3 times is the winner. Okay, so basically, Asa can win all the 3 and then game over. Kaiming can win all the 3, game over. Or the score can be 3-1. Or depends on the arrangement how they win. Or actually, all these 3 is the same. You can see, guys, these 3 are all the same, but it's just the position of the K. Can you guys see? Basically, where Kaiming wins the 1 set. Maybe he win the first set at the first time, or the second time, or the third time. 4th time, why cannot be at the 4th time, guys? Do you all know? Why cannot be A-A-A-K? Common sense. Why the K cannot be at the last spot here? Any idea? Why cannot be like this? A-A-A-K. You put the K here as another answer. Yes, because A already won. Okay, because when you win 3 games, it's considered win already. So K cannot be at the last. Alright? And then you do the same for K. K, K, A, K, K, A, K, K, and A, K, K, K. Okay? And then we extend some more. This one, 4 games. Then here, 5 games. You guys must see lah. Keep on arrange only. All these are the same actually, but it's just the arrangement of the K only. Okay, but I think this kind of question rarely come out in SPM lah, guys, because there are too many possibility. Okay, this is just to train your logical thinking only. Okay, nothing much. Alright, so don't worry too much on this. Okay, so basically you will have 20. Okay, can guys, for this part, 9.1, are you all clear? So basically this is 9.1, done already. Okay, this is how you do sample space. Alright, so now we go to 9.2. Okay, dependent events and independent events. Okay, this one very important for you guys to know. 200. Okay, so how to differentiate, before that, any question that you guys want to ask before we start this one? This one is a totally new subtopic already in this chapter. 9.1, nothing? All good? None. Okay, I think quite simple also. All right. Yes. Okay, because this one is quite confusing. Okay, first of all, you need to understand what is the meaning of dependent and independent events. Okay, very simple lah, guys. You just analyze this word from the English point of view. No need to talk about maths. What's the meaning of dependent and what's the meaning of independent? Okay, let's say if a person say you are dependent, means what? You depend on other people for stuff, maybe for transport or money or something like that. But you're independent means you can do everything on your own, correct? So this is the general thing. Okay, so basically when you talk about combined events, they can be categorized as dependent or independent events. Okay, dependent means 2 events, they will affect each other. Independent events means that 2 events, they do not affect each other. Okay, that's how we categorize combined events. Okay, so you guys can see here, event A and event B are independent. Okay, they are independent if the occurrence of event A has no effect on event B. Can you guys see? A no effect on B and B no effect on A. This is what we call as independent. Make sense, right, guys? Quite logic, right? Based on the word itself, you guys understand already, independent. Both of it don't affect each other. A don't affect B, B don't affect A. Clear on this part? So this is independent. Okay. So yeah, there's a lot of application in daily life. Okay. So if event A and B are dependent, means that the occurrence of event A affects the occurrence of event B. A affect B, B affect A. This is dependent event. They are dependent on each other. Okay. So that's how we see dependent and independent. Okay. So now this is a situation. Okay. So let's say they say that in case one, they choose a consonant card and not return to box P. Okay. They don't return the consonant to this box. Okay. So when you don't return the consonant to the box, guys, what does it affect? It affects the probability of selecting the second consonant. Correct? Why it affects, guys? Do you all know the reason? Why when you don't return the consonant card inside, it will affect probability? Simple. You guys can imagine and see also. What does it affect actually? Yes, very good. Okay, it affects the sample space because when you don't return the card inside, the total will -1 already. So automatic probability for second card change lah, because probability is what you want divide by the total. So if total change, automatically the whole value of fraction change already, no matter how much is the value on top. So that's the concept. Okay, that's why we call it as this one, guys. This one is called as dependent. Okay, because it will affect each other. Correct? The first event of choosing the first consonant card, when you don't return it, it will affect the second event of choosing the second consonant card. So that's why we call it dependent, affecting each other. Okay? So this is how you see it. Okay, how about case 2? Okay, case 2 is like this. Let's say, okay, they say the first consonant card is returned. They already returned, guys, to box P before the second card is chosen. Okay, so when you return the first card, does the total change, guys? May I know? Yes or no? Yeah, total doesn't change already. Okay, so if total doesn't change, at the bottom of the fraction, value will maintain the same. Okay, so it results in the probability of selecting second consonant will be the same as the probability of selecting the first consonant because it come back to original already when you return the card inside. So this is what we call as independent events. Okay, they do not affect each other because you already replaced the card inside. Does not affect each other. Okay, do you see the difference now, guys, between dependent and independent event? Simple, right? Not so difficult, right? Yeah. Okay, so now we see some daily life situation. They ask you to identify whether it's dependent or independent. Okay, so they say obtain a tail twice when a fair coin is tossed twice. So what do you all think? Dependent or independent? You want to get 2 times tail when you toss a coin 2 times. So does the first time you toss affect the second time you toss, or it doesn't affect? Okay, let's see. Okay, so about part A, yes, very good. Okay, the answer is independent event because probability of getting tail in first toss does not affect probability of getting tail in second toss. Okay, it does not matter, guys, because you toss once, you get tail. Second time you toss, you can get head, right? Doesn't mean you must get tail. So independent. Okay, it does not affect each other unless you toss in a way that you simply want to get the tail. You know there are ways, right, guys? You toss the coin so that you can get both times tail or both times head. That is already called bias, but they already say it's a fair coin. Okay, so when you take out all those bias things, then it's fair lah. Okay, you will be able to get various outcome. Doesn't mean you will get both times tail. Okay, so yeah. Okay, next one, part B. Okay, they say obtain a tail in tossing a fair coin and obtain the number 4 in rolling a fair dice. Got 2 things here, guys. So may I know, dependent or independent? Okay, let's see. Okay, so the answer is yes. Okay, it's independent event. Okay, independent event because the probability of getting a tail in fair coin does not affect the probability of getting number 4 in fair dice because there are 2 separate things, guys. Fair coin, fair dice. How can it affect each other? Impossible. 2 different objects. Okay, although it's the same person doing it, but it's still 2 different objects unless he's biased. But they already say it's fair. So independent. No other answer. Okay, so yeah. Okay, next situation. Obtain 2 pens of same color when 2 pens are taken out one by one from a container that has 3 red pen and 2 blue pen. Okay, keyword is here, guys, without replacement. You guys can always see this keyword. If you don't replace, will it be dependent or independent? You actually don't need to read the top statement. All of this you don't need to read. You just see the keyword. If they say you don't replace, will the probability affect each other or not? Yes or no? Without replacement. Yeah. Okay, so basically, if you don't replace, it will affect each other. Affect each other mean dependent event. Simple or not, guys? You don't need to see the first two line also. Direct, you see the keyword without replacement. Without replacement, automatically you think it will affect each other. Affect each other is what? Dependent event. You got your answer. Can you see, guys, the flow of idea? This is how you must think. Okay, dependent event because probability of getting first red pen affect probability of getting the second red pen because you never replace. Okay, never replace means total change. Total change, probability change. It's simple as that. Okay, in most case, dependent event need to multiply and independent use addition. Yes, correct. Most case. Okay, but of course you need to see the question first lah. Okay, always based on the question, whether you times or plus. Okay. Alright, next one, part D. Okay, so for part D, they say obtain 2 cards with same letter when 2 cards are chosen random. Okay, again, they emphasize the word random from the cards labeled by, okay, one by one. Okay, with replacement, guys. With replacement means what? Dependent or independent? You don't need to read the rest. Just look at the keyword. With replacement. Yeah, okay, with replacement tell you that it is independent. Why? Because the probability does not affect each other. Okay, probability of choosing first card does not affect. Okay, this is always the keyword. Does not affect the probability of choosing second card. Simple, right, guys? So now you already get the conclusion. If the situation tell you without replacement, automatic, dependent. With replacement, automatic, independent. You don't need to see the situation also. Just need to see the keyword. Okay? Can guys? So take note of this keyword. They always like to use in probability, with or without replacement. Always see it carefully. Okay? Alright. Any problem so far for this 4 questions just now? Still okay? Can no problem. Okay, another set of questions to determine whether it's dependent or independent. Okay, so they say a pointer of a lucky wheel stop at the same sector twice consecutively. So you guys think and see, dependent or independent? Over here, no keyword, so you need to base on the situation. So they say it stopped at the same sector twice, 2 times. I think you guys got play, right? This one, lucky wheel. Have you guys played this? If you play this, you will understand the situation well. If you never play, a bit hard. Okay, lucky wheel, basically, I think if you guys join contests, all that, they will ask you to spin, right? Especially in the shopping mall. Then you can win some voucher or free gift or something, right? So you guys think and see lah, when you spin it 2 times, the pointer stop at the same thing. So do you think it affect each other or doesn't affect each other? Anyone? Dependent or independent? Okay, so doesn't. Okay, let's see. Okay, so the answer is yeah. Okay, independent. It doesn't affect each other, guys. Okay, confirm won't affect because when you spin time, right, it's impossible when you spin 2 times it affect each other, right? Because when you spin, there's always a chance it can land up on a different place, right, from the first time. Okay, so it doesn't affect each other. Okay, so that's why independent. All right. Okay, so next one, question 2. Selection of 2 boys from a group of 10 girls and 14 boys at random. Okay, again, the keyword is random. So do you guys think dependent or independent? So you can imagine you have 10 girls and then you have 14 boys. Then you want to just choose 2 boys out of those. Total is 24 people. Okay, let's see. Okay, so the answer yes, dependent. Okay, why dependent? Because the total will, the 2 events will affect each other. Okay, because when you're choosing 2 boys, you will first choose 1 boy, right? You first choose 1 boy out of this, and then the total will decrease. Then you choose another boy. So the 2 probability are different already. So that's why it's dependent. It's going to affect each other. Okay, so yeah. Okay, next one. Answer 3 objective questions with 4 options correctly if the answer of each question is chosen at random. So you guys think dependent or independent? You want to answer 3 objective with 4 options correctly. This one quite relatable to you because you guys also got MCQ, right, in maths. So you guys can think and see. Let's say you imagine you got 3 MCQ, you got A, B, C, D, and then they say answer of each question is chosen at random. You just hentam. Random means you hentam. In other words, you hentam the answer for 3 objective questions. So does it affect each other or not? Yeah, of course it doesn't affect. That's why the answer is independent because you just hentam, right? When you hentam, how can the probability affect each other? Impossible. Okay, it's based on your will. Okay, you just hentam. Okay, so yeah. By the way, you guys got hentam before or not for maths? You can be honest, guys. Okay, even sometimes when you're desperate, right? Even if you're a smart student, you will still hentam one. Trust me. If you're desperate, no idea already how to do the question, you guys try your best, right? Just choose the answer that is most logic, most most makes sense to you, right? Yeah. This chapter only, yeah, correct. Okay, so it's okay to hentam, but of course try first lah before you hentam. Okay, hentam also hentam smart. Okay, you play smart and choose the correct option. Okay. All right, so next one, number 4. Box P contain 2 red cards and 3 black cards, while box Q contain 5 red cards and 6 green cards. Okay, so they say a card is chosen random P. Okay, they're going to choose from P and then put inside Q. And then they choose the card from Q. So guys, what do you all think? Dependent or independent? This situation very easy. You take from P a card and then you put inside Q. So you know already, is it going to affect each other, the probability? Yeah, okay, dependent. Okay, means it affect each other, correct? Okay, because you already changing the card from box P, you shift the card to box Q. So confirm the probability is going to affect each other. Okay, all right. So now, number 5. Vincent and Bajat sit for history test in school. Vincent and Bajat pass history test. Okay, common sense lah, guys. Does the probability of both of them passing affect each other? Yes or no? Two different people? Yeah, confirm independent lah, guys. Okay, if it affect each other, then you guys must investigate these two people very well already. Are they related by blood or related by DNA or by gene? I don't know. Okay, if you guys say dependent, means these two are, how to say, they are related to each other somehow. Okay, I don't know. So it's impossible. Okay, that the probability can affect each other. Okay, so yeah, independent. All right. So far clear, guys, until now. Before we continue, okay. So now, they're talking about probability of intersection of 2 independent events. Okay, 2 independent events means they do not affect each other. Okay, independent. So basically the formula is times. Okay, can you guys see? Whenever you have the word and, right, guys? And always means it is happening at the same time. Okay, common sense, right? When you use the word and is to show 2 things happening at the same time. Okay, when it's happening at the same time, you always use the time symbol. Okay, this is the rule. So probability A and B is 2 events. 2 events happening same time, you times them. Okay, is the product. Product means times of these 2 events. Okay, you get the concept for this one? Okay, so N, if you guys got study the Form 4 Chapter 4 set, do you all know N is actually what symbol? Union or intersect? This is actually related to your Form 4 Chapter 4 set. If you draw the set, you will understand. So basically, if it's affecting each other, means there is an intersection between the set. It's over here. Probability A and B is over here in the middle. Okay, you shade this region. It's affecting each other. So this one is union or intersect? May I know? When you shade this region. This symbol or this symbol? You got 2 symbols. If you use N, yes, N means intersect. Okay, the N symbol. Okay, intersect means it's in the middle. Alright? Means they are happening at the same time. Event A and also event B. 2 things at the same time. Alright? So yeah. So far can? So I try to relate this chapter a bit to your set also so that you guys can like relate to each other. Okay? Alright, so now they got 7 cards. This is an example, pameran. And then they say another box got 5 cards, 3, 5, 6, 8, 11. And they're choosing a card randomly from F and G. Okay, so they want you to find the formula, how to get probability of letter P and also even number. Guys, the keyword here is what? The keyword here is the N. Can you see? So N means what? Times or plus? May I know? When you see N, yes. K means times, correct. K means they are happening at the same time, correct. Okay, so now you need to list the possible outcomes. Okay, you can use the multiplication rule since it's happening at the same time. So you guys can see here, this is the first part. Okay, so probability of getting P, very simple guys. Total, you have 7 letters, right? So you're choosing 1 out of 7. That's why 1 over 7. Okay, and then probability of getting the even number, 6 and 8 are even numbers. So total 2 even numbers out of 5 over here. So 2 over 5. So probability of getting P and even number is you just times both based on the formula. This is directly based on the formula. You get 2 over 35. Okay, this is formula method, guys. First method. Second method is how? Second method, you list the number of outcomes. Okay, you list the possible outcomes. So how to get it? You can imagine based on the situation. Get letter P and also even number. So it can be P6 or P8, correct? The number of possible outcome. So you just list down P6, P8, curly bracket, and then sample space. You guys can use the multiplication rule. Okay, 7 over here, 5 over here. So total 35 outcome. So guys, can you see the answer is totally the same? Can you see? Two methods. First method is by using the formula of the probability. Okay, the times multiplication rule. Probability A times probability B. Second method is by using the listing. Okay, you list the possible outcome, find the total, then you get the answer. Okay, so understand both of the method, guys. You can show either one in the exam, depend on you. But if they specify, you guys use the correct method lah. If they say by using listing, then you start from this one, the one below here. Okay, listing is this one. On top is the formula of probability. If they say use formula, then you must show like this. Okay, but rarely in maths, they specify the method. Means you can use anything you like. Okay, usually they are quite free on this. Okay, so no need to worry. Okay, all right. This one very simple, guys. They just ask you to complete only based on the order. So basically 1, 1, 2, 1, 3, 1. You guys know how to do, right? Okay, quite simple. Just follow the order only. Use write the first number first and then the second number. Okay, so this one I think I need to show you guys. This is the answer. Directly you all can see. This one. Okay, clear, right? Question 1. No question on this. This one bonus mark lah, guys. Okay, very simple only. Just list down one by one everything. Just make sure don't do careless because got a lot of number here. Total got 36. Okay, so you must be careful when you write down. Okay, all right. Question B. Okay, they ask you to state the NS. So what is the NS, guys? Based on here, very simple. Sample space. How many? NS always refer to total. So anyone? Yeah, okay, total is 36. Very good. Okay, so the answer is 36. And then part C, they ask you verify. Again, use the formula of probability and also list possible outcome. Okay, so they want you to get odd number in the first dice and prime number in the second dice. Okay, guys, odd number. Can you guys list down for me among all these numbers here? Odd number is what? Just test your basic again. Very good. Okay, odd number is 1, 3, and 5. Okay, so that is for first dice. Prime number, second dice. So guys, can you list down prime number for me from 1 to 6? Yes. Okay, so yeah, very good. You guys can identify 2, 3, 5 is prime number. So basically, you guys can show like this. Okay, this is the possible outcome. Okay, you have 1, 2, 1, 3, 1, 5. This is by listing. 3, 2, 3, 3, 3, 5. You just repeat it only. 5, 2, 5, 3, 5, 5. This is the one you require because they want odd number first dice and then second dice, they want it to be the prime number. Okay, so basically you just follow the order only. And then the probability is 1 over 4. How you get 1 over 4? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Total 36. 9 over 36 is 1 over 4. Okay? You guys get the concept? Guys, I ask you a question here also. Can I leave my answer as 9 over 36 or not? Is it okay if I leave my final answer like this? Yes or no? Okay, why no? Why you say no? Yes. Okay, remember, always need to simplify your fraction. Very good. Okay, you must simplify so that it looks nicer also. Okay, 1 over 4, simplest form. All right. Okay, next one. Question 2. Okay, question 2, they say he choose 2 marble randomly from the box, which has 4 red, 3 yellow, and 1 green. Okay, so you're just choosing 2 out of total 8. 4 plus 3 plus 1. Okay, so they say first marble is returned to the box. Return to the box, guys. Keyword. Return to the box means what? Dependent or independent? May I know? You're returning the box. You're returning the marble. Yes. Okay, it will become independent. This one is return to the box means it's with replacement. Okay, this is come under the case of with replacement. So if your with replacement means that independent. Okay, it won't affect each other already. Okay, because the total will come the same. Okay, so yeah, they ask you what is the probability that 2 yellow marbles are chosen. Okay, you want to get both also yellow. First yellow, second also yellow. So first step, of course, you list the total outcomes lah. Okay, that you can get. Okay, so maybe can be, there are 3 yellow marbles. So you guys need to distinguish between them. How to distinguish? Just use 1, 2, 3. Label them like this. Okay, so it can be Y1, Y1. They are different, guys. Although same color, but the marbles are different. So that's why you need to separate. Or Y1, Y2, Y1, Y3. Then you just switch the number only. 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. Can you see, guys? So total 9. 9 out of total of 64 sample space. How to get 64? Based on this lah, you got 4 red marbles, 3 yellow, and also 1 green. So you want to choose 2 marble randomly. So basically, if you guys see, it's 8 power 2. You guys realize? 8, and then you power 2. You get 64. Don't times 2, guys. If you times 2, it's different answer. You will get 16. 8 times 2 is 16. Cannot. Okay, it's 8 power 2. Because you must remember, all these 4 red marbles are different. Within each other, they are also different. All these 3 yellow marbles, within each other, they are different. And this 1 green marble is 1 only lah. Okay, so that's why you need to power 2. 8 power 2, not 8 times 2. Okay, so that is how you get 64 at the bottom here. Okay, can guys? So the total outcome is 64. Clear? Question 2? Can. Understand? Okay. Next one. Question 3. Okay, so for box A, they say got 1 red card and 2 yellow card. Box B got 3 red card and also 1 yellow card. So this person is going to choose from box A and box B respectively, and she wants to get 2 yellow card. Okay, so how to get 2 yellow card from here? Okay, you're going to choose 1 from box A and you're going to choose 1 from box B. So again, you must distinguish them because 2 yellow card, you can label Y1, Y2. 3 red card, you can label R1, R2, R3. Just distinguish them. Okay, so that easier for you. Alright, so basically you can have Y1, Y and also Y2, Y. Okay, if you don't want to label Y3, it's okay. You can just label a Y there. So that is also meaning the third card. So basically, you have 2 out of 12. Okay, how to get 12? 12 is from here. You're going to choose 2 cards. Okay, here have 3 cards total. Here have 4 cards total. Correct? 3 red card and 1 yellow card. So 3 times 4 is 12. Okay, total outcome is 12. Again, we are using the multiplication rule. Why? Because it's happening at the same time. Okay, choosing a card from box A and box B, this event is happening at the same time. Okay, you can choose at the same time. From 2 box, you got 2 hand, you grab 2 cards at the same time. So that's why you can times. Okay, so 2 over 12, you simplify, you get 1 over 6. Okay, you guys understand? Question 3? Clear? Can. Is the pace okay, guys? Just want to check. Is it just right for y'all? Hopefully not too fast. Can just nice. Okay, we still got half an hour. I think can finish. Okay, so now how to determine probability of combined events for dependent and independent. Okay, so yeah, the question is they want you guys to calculate probability of getting a factor of 9 and also letter Z. Okay, guys, the keyword is here. N means what, guys? Yeah, I know. Times or plus? Yeah, okay, times, very good. Okay, if they say N means times. Okay, means it's happening at the same time. Okay, so they say they're going to choose one card from box A and box B, and you want to get, okay, factor of 9. Can you guys list down what are the factors of 9 from box A? They usually like to test all these things, factor, multiple, odd number, even number, you guys must know. This is your basic from lower form. Yes. Okay, factor of 9, very good. Your basic still strong is 3 and 9. Okay. Yes. Okay. Is that your final answer, Alex? 1 over 4? Final answer for this question? Okay, let's see. Okay, so they say you want to get, wait, yeah, it should be 1 over 6, Alex. Check and see. Okay, so basically you want to get factor of 9. There are two methods here. This is the first method on the left, right hand side, second method. Okay, so factor of 9, you got two factors out of total 4 in box A. So 2 over 4, or you can write 1 over 2, no problem. And if you want to get letter Z, is 1 over 3, correct? So based on the rule, if they say N, you just need to multiply both of the probability. You will get 1 over 6. Okay, this is the first method. Second method, we're using the listing. Okay, so you want to get factor of 9 and letter Z. So possibilities, you have two, 3Z and also 9Z. Very simple. And then sample space, 4 over here, 3 over here. So 4 times 3, you get 12. So 2 over 12, 1 over 6 or so. Okay, understand? Both of you? You can show either one. Depend on you guys. Okay, can Alright. Okay, next one. Example 5. Okay, they say there is a bag. It has 8 green marble and also a red marble. And they want to choose 2 marble one by one. Okay, this is the keyword, one by one. Without replacement. Guys, without replacement. Dependent or independent? May I know? This is the keyword already. If you don't replace the marble. Yes. Okay, very good. If you don't replace, the total is going to change. Total change, dependent event. It will affect each other. Okay, that's how you guys must think. Okay, now you guys need to know about tree diagram also. Do you guys know how to do this? Have you done this before in any exercise you did? Tree diagram? I think it's quite simple to draw it. Yeah. Okay, tree diagram very useful for probability. You guys can see here. Basically, you have two marble, so green and red, G and R. So green, you got 8 green marbles. Total marble is 9 because 8 green, 1 red, total 9. So 8 over 9 green, 1 over 9 red. Okay, since they say without replacement, the probability will affect each other. So that's why you guys can see the probability here and here is different because it's a dependent event. Okay, so for the green, since you already take out first marble green, total will decrease by 1, correct? So 9 become 8. And then the number of green marble also decrease by 1 because your first marble already green. So that's why from 8 becomes 7. Total decrease 1. Okay? Sometimes I got confused when to use T diagram. You mean when you should draw it, is it this one? Oh, of course, if the question say by using tree diagram, confirm you must draw. But if the question never say this, let's say the question just say represent the above situation, they never say use tree diagram, better to still use it. Okay, because if you draw like this, it's much easier to see, right? Do you agree? Rather than you just imagine this whole thing in your mind. Yeah. If you can imagine, no problem. Some people, they really can imagine what is happening. It's okay, can. But to avoid careless mistake, better draw like this lah, guys. More organized, right? You see like this also easier for you rather than you imagine 3 things happening one shot in your mind. Okay, so yeah, better draw this. Always for probability, just draw this out. Very simple. Although no marks, better draw. Okay, so that you can get the marks for the next question. Okay, all right. So now Okay, let me explain this one first. Okay, let's say the first marble you choose green, so 8/9, but the second marble you choose red. So total will still decrease by 1 because you already take out one green marble, and red marble you only got 1. So that's why it's 1/8. Okay, and then the last one, let's say you choose red. Okay, 1/9, first one. Then let's say next you choose green. Okay, so you choose one marble, total decrease by 1. 9 become 8. Green, you still got 8 marble because the first one you chose is red. So it's still 8/8. So guys, over here, right, 8/8, if you guys write 1, also can, no problem. Means 100% you will get a green marble. Common sense, right guys? Because you already choose the first marble is red. So you got no red marble. No red marble means 8 green. Confirm you will get green lah. So it's 100%. For the second marble will be green for this case. Okay. Now I ask you guys, why there is no R here? Anyone can tell me? Why over here don't have a R? Why only if first marble red, confirm second one green? Why cannot be red again? This one logic lah guys. Because some people will see the pattern, G, 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 R, R, G should have R, R, what? Yeah, very good. Okay, no more already guys. You have one red marble only. If the first marble is red, you take 0. So you cannot have a second marble that is red. Unless magic happened lah guys. One of the green marble changed to red, that is a different story lah. Okay, but we cannot talk about magic in maths. Okay, in maths there is no magic. Okay, it's only reality only. Reality is you got 8 green marble. Okay, so this one is impossible. No need to show this. Okay, because there is no probability. Okay, all right. So now they ask you calculate the probability. Second marble is red. So guys, can you see when you list like this, right? You already know second marble red. This one you don't see because second marble green. This one you don't see because second marble green. So final answer 8/9, 1/8. Do I times or plus? Yeah, I know. Now we are focused on this root. This one and this one. So do you times or plus? Yeah, times. Why times? May I know? Always you guys must ask this question. When you do something in maths, why? Yes, okay, because it is dependent. Okay, it will affect each other. Okay, so 8/9 times 1/8. You get 1/9. Okay, basically you can also say it's happening at the same time. Okay, it's happening at the same time. So that's why you times. Okay, 1/9. First marble and second marble. Okay, all right. Now they say both are green marbles. Both are green marbles means you're referring to the first situation. So basically 8/9 times 7/8. Done. 7/9. Okay. Simple, right guys? This is the importance of drawing the tree diagram. Can you see now, Shane? Why, and also Alex, why we draw tree diagram? So that you see the following question, right? Very simple to answer. You just follow the root only. If you imagine this in your mind, quite difficult. Okay, you might get wrong over here in part 1 and 2. Okay, all right, next one. Okay, this is the last 6 questions. I think we can complete. This is the last already. Any question up till now? Anything that you want to ask before we go through this? Can. Okay. All right, so let's see question 1. Okay, so they say box K and box L, they contain 4 cards we label with by you and also 3 cards labeled with 1 to 5. Okay, so basically 4 and 3 here. And they say choose randomly from box K and box L. Okay, so they want you to list the possible outcomes. Okay, when the question say like this, make sure you guys list. Okay, don't direct suddenly appear the number there. How the number come from, you must list down all your sample space one by one. Okay, they want you to get vowel and also even number. Okay, vowel guys, may I know where is the vowel? Box K, can you list? Make sure you guys know all this. Very good. Okay, sometimes basic stuff also people don't know. Okay, make sure you guys know difference between vowel and consonant. Okay, A and U, and then even number guys over here. Yes, very good. Okay, it's a 2. So now you already identify. So now you list N. Okay, the keyword is N. So guys, N means times. Okay, happening at the same time. Both events happening same time. So possibility can be A2 or can be U2. Correct? They want it to happen at the same time. So you guys can see here. Yeah. Okay, A2 and U2. And the probability is 1 over 6. Okay, how to get 1 over 6? Because you got two things that fulfill the requirement, and total 4 over here, 3 over here. So 4 times 3 is 12. So 2 over 12 is 1 over 6. Understand, guys? Question 1. Just need to use the multiplication rule only. Okay, can Okay, next one. Number 2. Okay, so they say there is a fair dice with 4 face. Okay, dice can also be 4 face, guys. Take note. Doesn't mean must be 1 to 6 always. It can be 1 to 4 also. 1 to 4, the dice look like this. Okay, have you guys seen this kind of dice? I don't think now got, right? This one looks awkward a bit. Yeah, usually it's the square one. Because square has 6 sides, so you have to have 1 to 6. If you want to have 4 sides, then it's a pyramid already. So that's why the dice is like this. Okay, 1 to 4. Okay, never mind. Just assume it's 4. So they say dice is rolled twice. Okay, you're going to roll this dice twice. And they say they want to record the number that you get. Okay, so they want you to list all the outcome, and they want you to find probability of getting 2 odd numbers. Okay, you roll 2 times, you want to get 2 odd numbers. So now, guys, you see here, what are the odd numbers? May I know? 1 to 4. Yes, okay, odd number is 1 and 3. Okay, so you want to get probability of getting these 2 odd numbers, 1 and 3. Okay, so basically it's like this. You can have 1, 1, 1, 3, 3, 1, 3, 3. Okay, you must list down these 2 as separate ones. Cannot choose either one. Why? Because you are rolling 2 dices. Okay, when you roll 2 dices, the order is important. Okay, 1, 3 is different from 3, 1. Okay, so that's why you need to separate it. All right, so over here, you have to find the probability. Okay, probability of getting 2 odd numbers. So basically, the case, okay, since you got 4 numbers here and then you roll it twice, so 4 times 2 is 8, right? So your total is going to be 8. Sample space 8. Okay, sample space 8. Total number that you get here, total number of cases is 4. So 4 over, wait. Sorry. Wait. Mistake. Hey, sorry, not 4 times 2. Sorry, make mistake here. It's 4 faces. Okay, 4 faces with 4 number. This one don't see. Okay, 4 times 4. Okay, total is 16. Okay, you got 4 faces and then label 1 to 4. Okay, so total you can have 16 sample space. Okay, your total cases is 16. And then you have 4 over here. So 4 over 16. You simplify, you get 1 over 4. Okay, that's the concept. Okay, clear, guys? How to get this? Can. Okay. Just need to imagine the situation only in your mind. Then you can get it. Okay, so now question 3. They say probability of rainfall on mountain X in May is 0.45. Okay, so they want you to count the probability. It will have 2 consecutive rainy days in May. Means let's say 6 May and 7 May both also rain. Or maybe 23 May and 24 May also rain. So they want you to count. What's the probability? Okay, first of all, you guys must know. May got how many days, guys? May I know? This one, if you guys don't know, very hard. Lucky you guys know 31. Okay, some people will say 30. Okay, wrong. 30 is the general. The general assumption for the number of days in each month is 30 because majority of the month is 30. But if you talk about specific month, you need to see it carefully. Like May is 31. Okay, so basically, you should get 0.2025. Okay, so if you want to have 2 consecutive rainy days, wait, let me count now. Need to use calculator. Okay, so if you want to have 2 consecutive rainy days and you have 31 days, okay, so basically 2 over 31. Let me see. 2 over 31 times 0.45. 0.02025. Wait, guys, let me think. 2 consecutive rainy days. Okay, so they say probability of rainfall on mountain X is 0.45. Okay, so 0.45 is for any day lah. Okay, one day is 0.45. So you want to have 2 times, means that 0.45 times 0.45. And then You want it to happen 2 consecutive days. Okay, so basically just times both only lah guys. Okay, no need to consider how it occurs. Just 0.45 times 0.45. Okay, 0.2025 is the answer. That's all. Okay, get the concept. Basically, you just need to do this 2 times or 0.45 power 2 since they say 2 consecutive rainy days. Okay, so we don't care lah guys when it happened, whether it's 6 May, 7 May or 7 May, 8 May, it doesn't matter. All right, are you guys clear? Question 3, just 0.45 power 2. That's all. Okay, can clear. All right. Okay, so question 4. They say there are 5 cards labeled with the letters Chile. 2 cards taken out randomly, one by one, without replacement, guys. Okay, without replacement, may I know? Dependent or independent? Yes. Okay, so without replacement means that the probability is going to affect each other because the total will decrease. Okay, so without replacement. And then they say you want to get first card consonant, second card vowel. So you guys can list down lah one by one. Okay, consonant means CLK, vowel means EI. So you guys just need to pair them only. Like C pair with E, C pair with I, and then L pair with E, L pair with I, K, E, K, I. This is how you get it. Okay, so your probability is going to be like this. Okay, you have total 1, 2, 3, 4, 5, 6 over here. Consonant must be first and then only vowel. So you got 6 out of total of 20. Okay, your sample space will be 20 because here got 5 cards. Okay, 5 cards. And then they say that first card must be consonant, second card must be vowel. So you need to times 2. Okay, times 2 because 2 cards. And then again also times 2. Times 2 for the order. Okay, first card consonant and then second card vowel. Okay, so 5 times 2 times 2, 20. Okay, 20 and then you got 6 here. So 6 over 20, simplify 3 over 10. Okay, do you guys get it? If you guys want, you can list down also your sample space over here. Totally. When you take out 2 cards randomly, one by one, CE, CL, CI, CK, you can do like that also. EC, EL, EI, EK. You guys see it? So basically, you got 4 pairs. 4 pairs, and then you got 5 letters. So 5 times 4, 20. Do you see it, guys? You can see it that way also. Okay? So like that. Can if you list down, very simple, guys. You list down one by one, you can see the situation already. If you imagine in your mind, also can. But you might make careless, so better to list down. Okay? Alright. So next one. By the way, you guys tired or not? Okay, right? Still can cope, right? Because sometimes I scared you guys not used to this kind of maths. Very, how to say? No break at all. Okay, can. Alright. Okay, so next one. Question 5. Okay, so they say box contains 12 bulbs where 2 of the bulbs are burnt. Okay, so over here you can see got 12 and then they say 2 are burnt. Okay, so they say 2 bulbs are selected at random from the box. Okay, again you guys see the keyword, it must be random. Okay, random is important. And they say by sketching 3 diagrams. So guys, whether you like it or not, you need to sketch 3 diagrams. Okay, they say calculate the probability of getting 2 burn bulbs. Okay, you want to get 2 burn bulbs out of the 12. Okay, so you're going to select it randomly. Okay, so basically you can do like this. Just label it like this. Burn bulb is B, not burn bulb is B prime. Do you guys know why we use prime here? Both of you? What is the meaning of the prime over here? Instead, you guys learn the function of prime. What's the function of that apostrophe on top? Yes, outside of set, or you can also say the complement. Okay, complement of the set means the opposite of it lah. Okay, opposite of burn bulb is not burn bulb. Okay, so that's why we use B prime. If you guys want to label NB, also can, no problem. Not burn. Okay, can also. No need to use B prime also. Okay, but over here they use B prime. Okay, so burn bulb, they say that there is 2, right, out of 12. So that's why total is, the probability is 2 over 12. So if this 2 over 12, this will be the remainder. 1 minus 2 over 12 is 10 over 12. Okay, and then they say that it is, okay, they never mention anything here, guys. Okay, if they never mention anything, right, means what? Do you all know? They didn't say with replacement or without replacement. So you have to assume. You have to assume it is without replacement. Okay, if question never say anything, right, guys, you assume that you are not replacing the bulb inside. Are you clear? Can you see why? Because the total is decreasing by 1. Okay, if question never say anything, take note. Always assume it's without replacement. If there is replacement, the question must tell you. They will say with replacement, or they say the bulb is added back inside the box. They have to say something like that. If never say anything, straight away assume no replacement. Okay, that's how it works in this chapter. Okay, so yeah, basically just decrease probability by 1 for your second burn bulb, and then the number also will decrease by 1 because you already chose 1. Okay, and then for second case, not burn bulb as the second one. So again, total decrease by 1 because you've chosen first burn bulb, and the number is still the same. 10 is your number of not burn bulb. Okay, and then yeah, same thing again. Burn bulb, total decrease by 1, and then you still got the 2 here because the first one is not burnt. Okay, and then the last one, again, total decrease by 1, not burnt, and also the number on top decrease by 1 because your first one is not burnt. Okay, do you understand, guys, these 3 diagram, how to draw it? Clear? Can, okay, if you guys want, you guys can write the outcome here also. Usually the complete 3 diagram, they will write the outcome. You guys know, right? They'll write like BB and then B, B prime, something like this. You guys can write also. Just write the word outcome on top, and then you just list down all of this based on the order. Okay, this method also can, to make it more complete and easier for you guys to answer the following question. Okay, understand? No problem, so guys, simple or not? Probability. Simple, right? Who say very difficult? Simple kan? Just don't think too complex. That's the thing. Okay. So now they want you to get 2 burn bulb. Okay. So 2 burn bulb means that B and B. So first case lah, multiply. Okay. 2 over 12. 2 over 12 multiply with 1 over 11. So if you simplify, you should get 1 over 66. Let me check. 2 over 12 times 1 over 11. Yeah. Okay, answer is 1 over 66. Just multiply these two. Okay. Can, guys? Question 5. Clear? Okay, last one. Question 6. Then habis. Wow, right on time. Wow, my planning is perfect today. 2 subtopic is just nice. 1 hour 30 minutes. Okay, so science and mathematics. SMK Didek Jaya. Okay, so this one, morning session, female 146, male 124. Afternoon, 82 female, male 96. Okay. Okay, Science and Math Society, they want to select 2 randomly. Okay, be careful, guys. Why? Because there are many variables here. First variable is we are talking about the session, morning or afternoon. Second variable is what? It can be female or male. So there are 2 categories here, guys, you need to be careful of. When you find the probability, you need to consider these 2 things, whether morning or afternoon, whether female or male. So there can be many pairings here. It can be female morning, female afternoon, male morning, male afternoon. Do you see that, guys? There are many possibilities. Okay, so always check what the question wants. Okay, they select random from the male members. This is the important keyword. So guys, when they say 2 members are selected randomly from the male members, means what? Means this one is going to be your total. Correct? Because their sample space now is only focused on the male member. So you need to find the total of male member. We don't care whether it's from morning or afternoon. Our focus is it must be male member. Can you see, guys, what you must focus on which one? Based on the question always. So over here, we focus on gender. Okay, we don't care about the session, whether morning or afternoon. So 124 plus 96, you will get 220. Correct? Yeah, okay, 220. So that is your total. Means below the fraction is 220. And then now comes the question. Both members must be morning session. So that is the requirement. Okay, so morning session, male. So you just need to look here lah. Am I right? And your total you consider among the male only. Okay, so first probability basically 124 over 240. And then second probability, does it change, guys? May I know? for the second member? Yeah, of course going to change lah because you already took out one male, right? So the total decreased by 1. And then the male on top also decreased by 1, the number. Okay, then you just multiply it. You should get 0.3166. Okay, let me check. 124 over 240 times 123 over 239. Wait. 0.3166. Wait, probability that both members are chosen. Morning session from the male. Okay, wait, 124 plus 96, 220. I think I write wrongly. Wait, let me see. 219. Yeah, correct. Okay, 0.3166, correct. Okay, so your probability is 124 over 220, 124 over 220 times 123 over 219. Okay, do you guys get it? That's how you get this one, 0.3166. Okay, so that is for part A. Remember, follow the question now, guys. 4 significant figure must give to 4 SF. Okay, 4 SF means what? 4 digit over here. Okay, follow the question always. All right, next one. Okay, so now they say 2 member from the afternoon session. So now, guys, the priority is on the timing, correct? So your total only focus on afternoon. We don't care what is the gender now for the total. Okay, so 82 plus 96, total 178. Okay, so over 178. And they want it to be both female. So you see female lah, guys, 82, right? So 82 over 178, first member. Second member, does it change, guys? May I know the total and the number for second fraction? Both female, yeah, of course change. Okay, because the total will decrease by 1 and the number of female also decrease by 1 after you choose first female. So basically 82 over 178 times 81 over 177. So this is the answer, 0.2108. Okay, again for SF, remember that. Okay, are you clear, guys, with this question? Number B, simple, can get. Can savior? Oh, I'm the savior, is it? Savior for this topic. Simple or not, guys? Simple, right? Understand? Can. Okay, good. Okay, so any question about this whole topic? About these 2 subtopics, not the whole topic. Can Eddie? Can get. Okay, that's good. Okay, so anything that you want to ask? All clear? Good. Wow, not bad. So how did I do? Okay or not okay?